All right, welcome back to Mr. P. House with Algebra 2. This is Unit 1, Topic 3, SLT number 18. So we're going to be deriving the number E. The number E, yes. E is about 2.718, which we'll talk about later, and explore exponential functions that model continuous growth and decay. So in this case, we're going to be talking about compound interest. So Ron deposits $1 into this bank account. It's going to get 100% interest, which would be great if that was in real life, but that's not really what it is. But that's what we're going to use, 100% interest. And he's going to put it in there for 1 year, and we want to figure out how much money is he going to have at the end of the year. Now, it depends on how many times it's compounded. Compounded means if you put your dollar into the account and you get 100% interest, at the end of the year, you would get 1% interest because that's 100% of $1. But if that's yearly. So your future value would have $2 total. So you would get an increase of $1. So if you do it semi-annually, that means twice a year. So that means you're compounding it twice a year. Quarterly would mean 4 times a year. Monthly would mean 12 times a year. Weekly would be 52 times a year. Now this is where it's going to get a little bit difficult. So daily would be 365 times a year. Hourly, so you got to multiply 365 times 24 hours in a day. So that's 8,760 times a year. And if you do that every minute times 60 again, times 60 in this case because there's 60 minutes per hour. So that means there are 525,600 minutes in a year. All right, so what is the equation? The equation in this case is principal times 1 plus the rate divided by n. N is how many times it's compounded to the nt power. So t represents the amount of time, r represents the rate, and p represents the principal amounts that you started with in the beginning. So now, if you do it yearly, that's once a year. So r divided by 1, well, that's still the rate divided by 1, and 100% is 1. Remember, 100%, move the decimal twice, is 1. 1 divided by 1 is 1. 1 plus 1 is 2. 2 to the power of 1 times 1 is also 1. 2 to the power of 1 is 2, and then so you're just doubling your money. So which means double the $1 you had to begin with. But I had already talked that one through anyway. Now, what if you're doing it semi-annually? So what's happening is if you compound in the middle of the year, you're going to make interest for the first half of the year, plus you're going to make interest on that interest for the second half of the year. So that's 1 plus the rate, which is still 1, 1 divided by 2. So this is 1 plus 1 divided by 2. So the rate is 100%, which is 1, to the nt power, so which is 2. Now you're dividing that number into 2 equal amounts for the half of the year, but then you're going to do it to the power of 2 times 1 year. So the principal amount was $1. So 1 plus 1 divided by 2 is a half. So 1 plus a half, so that's 1.5 to the second power, and then multiply that by the $1 you had to begin with, means you have $2.25. So what you've now noticed is that you've made 25 cents of interest on the 50 cents of interest that you got the first half of the year. So that's the reason why you ended up with more money in the end. Now I'm going to do this again. So that's the initial amount of money I have plus the rate plus 1 divided by 4 to the 4 times 1 power, because it's 4 times a year. That's n times 1 year. So 1 plus a fourth would be 1.25 to the power of 4 equals, and times 1 is going to be $2, about $2.44. So what you're now noticing is the more times you compound, the more times you're going to get interest on your interest. So as you keep going, you'll notice that the number is going to keep growing. So if you do it 12, so that's 1 divided by 12 plus the 1 to the 12th power, which is going to be $2.61. You can see what I did right there. I don't know if you can see that. Ooh. Oh, there we go. That's better. Okay, so 52 times a year. So that would be 1 divided by, clear that out, 1 divided by 52 plus the 1 to the 52nd power, which is $2.69. Now, what you're probably noticing is now the number increased a lot in the beginning, but now it's not increasing so much because you've compounded so many times that you're not seeing that much more interest given. So now most banks are going to compound it 365 times a year, which is once a day. So 1 divided by 365 plus the 1 for the rate to the 365th power means you're going to get about $2.71. Now, you can continue doing this, and you're going to notice that these numbers, I'll skip right to the last one, so 1 divided by 525, 600. All right, and do that plus 1 to the 525,600 power, which means you're going to make about 2.71827. Now, this is the absolute most. Now, you can do it to the million if you want, but it's not going to increase very much at this point. And that is E. That's Euler's rule. Euler is about, Euler's number is about 2.718. That is the absolute most money that you can get. That's 100% interest for 1 year. So that's the absolute most that you could possibly get. If you continuously compound it every split second, you can't make more money than 2.718. All right, so how will you describe what's happening to the value? Okay, so it's increased. I've already said that. Will the future value of the account after 1 year reach $100? No, it's not. The absolute most it could ever be is $2.71, give or take 72 cents. Now, it is an irrational number, which means that it's going to go on forever and ever. It's kind of like pi. It doesn't end. Discussion points. What is the significance of the account? Okay, so I think I've talked about that. So annually, I think I've met this. Okay, so let's just do a practice problem, and that'll be it. So you deposit $975. Now, continuous growth, you don't need to use the compound interest. You can use P times E, which is 2.718, to the RT power, otherwise known as PERT. So if you input $975 into your bank account, and you multiply that by E, which represents the total amount, that's the absolute most money that you can make if you compound it continuously, to the rate of 5.5%, which is 0.055, because you got to move the decimal twice to the left, times T, how many years? That would be 6 years. All right, so there we go. So we've got it. So E on your calculator, you press second, and then you'll notice it's on the ln for natural log. Okay, so it looks like this. There we go. That's better. All right, so E to the power of, that's 0.055 times 6 in parentheses, and that gave me about 1.39. I'm now going to multiply that number by 975, and that tells me the absolute most money you could possibly get continuous growth is $1,356.19. That's not bad, because you start off with less than $1,000, so it looks like you've increased your money by almost $400. All right, so that's an example. If you divide it $2,500 and pay 6% interest, if it does continuously. So this is basically to figure out how it's going to change differently as time goes on. But I think I've described E. So please give this video a like if I've helped you understand what really E represents. That's really what this is all about. The reason why it's 2.718 is because that's the absolute most growth you can get on 100% growth for 1 year. All right, thanks again for watching. Have a great day.